So I'm Tariq at Codasip in Bristol. I think I probably know at least a quarter of the people here looking around. So I've been actually looking at Cherry, I think, for 5 years now. I was trying to work out how long I was looking at it for in Huawei before I joined Codasip, but I'm pretty sure it's a whole year. And I've been in Codasip for nearly 4 years now. So I think we got the GitHub set up for RISC-V CHERI in January last year, so January 24, when we put our sort of internal version of the CHERI spec aligned to the university spec onto GitHub. Since then, we've had something like 550 pull requests and about 260 issues closed. And it's been a very long process, but we're getting there. Hopefully, we're getting there. So I'm going to talk about bases, briefly about the profile, not a lot about that. And also over the last, how many months? Since we did the implementation on the FPGA running Linux out there, there have been quite a few changes to the spec. All of them have come from RISC-V feedback. So it hasn't been us causing them, it's just what we've been told to change. So I think when I first started speaking to the Cambridge University folk in Barcelona, which was the RISC-V Summit 23 in the summer, RISC-V was still calling CHERI a different universe because it just seemed so different. But we've managed to sort of simplify and converge it and make it fit much better these days. There's still been a lot of discussion about how to actually really make it fit. And the ruling these days is that if existing instructions change definition, then it needs to be another base architecture. And CHERI very clearly falls into this category because we changed the way that branches execute because we could go unrepresentable, and we changed the way loads and stores execute because of the capability formats. I think RISC-V are going to start to be more rigorous about this because there are other places which they call extensions, but actually need to become base architectures, including one of my other extensions, Z things there, for example. We don't have guidance on naming yet, which we're waiting for. As a point of reference, I think from having the GitHub set up for the code size reduction extensions, I think it took 5 years to get actually ratified. So it's a long process. So it says CHERI is going to be a set of base architectures. Apologies for the text being a bit small. It's a bit small for me to read as well. So we have obviously different encoding formats. We have the RV64 format, and then we have the two different RV32 formats. So each of them needs to become a base architecture because it simply behaves differently. Now, for every base architecture, there's a lot of work we have to do. We need to produce a sale model, we need to have a test plan, we need to produce tests, and obviously we need the specification, you need an RS port, proof of concept, and there's a great big long list of things that we need to do for each of these. So each of these is quite a considerable amount of work. So RV64 format is the same as it's been forever. Basically, it's the CHERI concentrate. And RV32Y is obviously more difficult because of the limited encoding space. So we have agreement with RISC-V to allow us to add more encoding formats over time as we need them. But every encoding format needs to go through the same rigorous process of sale model, tests, OS port, and so on and so on and so on to be ratified. Everyone is, it's quite a serious thing to add. Okay, so is this up to date? So extension list. So we spent a lot of time over the last year or so aligning between University CHERI and CHERIoT CHERI, having diverged some time in the past. So one thing we've done is separate out the sentries, for example, from University CHERI because CHERIoT handles them separately, so they can't go into the base because the base is common. So it's base plus encoding format. So you will always have the same set of base instructions, whatever your encoding format is, which can't include sentries because they are used differently, which is fine, not a problem at all. Information flow control, the levels with just 2 levels we've done as an extension because when we move to multi-level we may find that there are better ways of encoding it, so we didn't want to bake that in. It may not be extendable in the 32-bit format as it's currently specified. There's hybrid, which is where we switch modes between compatibility mode and CHERI mode. So this can be orthogonal to the encoding format, but if that's the case, the mode bit needs to be encoded in the format. So any encoding format can do that, but it needs to be encoded somehow. And a couple of other things, you've got the CHERIoT version of sealing and the byte half load reserved store conditional instructions. Okay, so that's unprivileged. So for privileged, we've got the revocation scheme in the page table entries and machinist supervisor ISA. It's all fairly straightforward, really, I think, and all very stable and again up and running on the demo outside. So lots of the existing extensions are modified for CHERI, which is another reason why it needs to be a base. So if you add, for example, say the ZBA extension, which adds shift and add instructions, then you'll get your integer shift and add, but you'll also get the CHERI versions of shift and add. So you get a capability shift and add as well on top. And there are various other things we've had to change, like the compressed instructions, where you're adding the stack pointer, you're now adding the capability stack pointer. So it needs to be a capability add. And capability CSRs are a bit different. For atomics, we've only got ammo swap.y. We'd like to have the other types, but we need the bus fabric to support capability arithmetic, which we don't have yet. Things like cache flushing or cache invalidation certainly is really quite dangerous, especially with CHERI, as you may expose stale capabilities. So for the ZIC, BO, and then I've forgotten which one of those is invalidate. VM, thank you. We add additional permission checks to make sure that the use of the invalidate instruction is properly guarded. And we also have just proposals at the moment for 2 of my extensions, the push pop and the table jump. We have sort of sketches of how they may look under CHERI, but I'm not going to worry too much about those for the time being. There's a lot more important things to get done. The hypervisor, we have prototypes going. We certainly have it on CVA 6. I don't believe we've seen the full software running yet. When we do, we can put that forward for ratification with everything else. Vector we think is fine, actually, having discussed it fairly recently. That should just go through because you just check every active byte and that's it against the capability. And pointer masking, I don't think the spec is particularly correct. There was an idea of not doing it the same way as Morello, but I think what we've come up with doesn't work properly. So again, not worrying about that too much for the time being. But the idea is to get all of the extensions from RVA'23, the application core profile, working and compatible with CHERI. That's the main goal here. So because the hypervisor isn't stable yet, we've gone for an RVYB proposal. RVYB is the application core, but without hypervisor or vector being mandatory. So we thought it was simpler to start with an RVYB proposal, so that would be put through for ratification at the same time as the specification. The current proposal is in that issue there, issue number 802. And yeah, it's identical to the standard RVB, except that obviously we have CHERI additions to it, and the pointer masking is postponed until we have time to look at it properly. Okay, so I've got 6 minutes left. So the last few slides are a much more detailed list of what's changed since we've been in ARC review. And none of them are very exciting, and there are quite a few. I may get to the end, I may not. But the point was to have them all in the slide deck, which will then be uploaded, presumably, and then people can look at it if they're porting their designs between the two. So CHERI for a long time prefixed all instructions with C. So a normal load would then be, load double would be CLD. And the PC got renamed to the PCC, the stack pointer the CSP, and so on and so on. So that has all been removed to ease software porting. So if you're just loading a word from register X2, you still load a word from register X2, whether it's Cherry code or normal code now. So you don't need to port your software, port your assembler syntax anymore. And the other thing was we needed to choose a letter, basically, to support, to represent Cherry. Letter C had gone some time ago for capability instructions. The letter Y was available and in the word capability. So now Y is everywhere. So if you're wondering why, that's why. Terrible joke. But yes. So CLen, wherever we used a C, we've either deleted the C or we've changed it to a Y. And that's pretty much it. So YLen is the width of the registers. So we had renamed some existing instructions, like AUIPC had become AUIPCC, and we still refer to it as such quite a lot because it just comes off the tongue. But actually it's really just AUIPC now. It's just on a Cherry machine, assuming you're not in hybrid mode. AUIPC will return the capability, PC capability plus offset. And there's a list of instructions there, which were previously renamed, but now have the normal name in them again. The exception being C.YMV, to make it clear that you're copying a full capability and not a normal register, because otherwise you can't tell once it's been expanded, I think. Yeah, so repeating there. So the data type is Y for capability. So load capability is LY, store capability is SY, and so on, and the compressed form, stack pointer relative. And the load reserve, store conditional, ammo swap, and the hypervisor instructions are all Y types. So no longer a CAD. The data type goes at the end, which is a Y, and so it's called add Y or addy, whatever you want to call it. And the versions of the shift and adds now have a Y at the end of the add, so it's shift 1, 2, 3 for add Y. All very dull, but you know, it's all stuff that's changed. Okay, so YLen arithmetic. So all our registers have now doubled in width, and we want to be able to, in the future, make more use of that. So the formerly, it's changed the name too many times, set cap high instruction, which is now called something else, which I think is on the next slide, is now a pack Y instruction because you're taking two XLen values and packing them into a YLen register. And the C get high, the get the metadata, is now a 64-place shift. The point here is that we want to be able to add more 128-bit instructions, or double XLen instructions in the future. For things like RV32Y with floating point, you might want to get your 30 floating point values in your integer register file. Or V and Y, so vector in your integer, well, capability registers, for example, all for the future. So there's the renaming table. So it's got the new and the old names. So Y tag R, so everything pretty much is prefixed with a Y, and then tag, and then R for read. It used to be get capability tag, and so on. So pretty much everything's prefixed with a Y. So all very exciting. It's there for reference. That's sort of the point. And the next set. Okay, but again, I'm sure the slides will be uploaded. And that's the last one. We got rid of the integer shift4 add because we couldn't find any good use for it. Okay, so we said ZYS, we've separated out the century instruction, we've removed, we did have shift4 add as a separate extension before because we thought the integer version might be useful. It's turned out not to be, so we've just included the Cherry version into ZBA on a Cherry machine, and we took ZY levels 1 out of the base because it may not be useful once you go to more than 2 levels. This was just a reference for what we did with the compressed load store mapping. 24 seconds. Integrity checks. lots of the instructions had integrity checks, but we put different integrity checks on different instructions, and I basically merged them all. So all instructions just check all or none of the cases to make it a bit simpler. C build changed a bit for CHERIoT. There goes the beep. A little bit on ZY levels. I think that's... There you go. just before you throw me off, on David's suggestion, we pulled out some illegals from the branches to make room for things like branch if tag set or branch if tag clear in the future. We took branch target exceptions off. These should have been earlier in the list, really. And yeah, that'll do. Okay.